So, a very good morning, guys. Again, as you know, my name is Chahil, and today we are going to make one more video. And in this video, we are going to talk about a project that I made, and it is one of the best projects that I have ever worked on. And you can see that we have currently opened the GitHub repository, and the name of the project is SQLens. So here you can see that it is an ultimate SQL performance analyzer. So let's just take a real world problem where you are given to work with an SQL and you are like a database administrator. So you have to ensure that you use your queries efficiently and optimize it as much as possible so that it takes less time to give you results and the query is more perfect. And here we can see that like nowadays everyone knows how to write queries, but a very few of the people they know how to optimize it and make it better so that it takes very less time, because in real world there are millions of records and rows and data. So here we can see that there are like some of the key features is it is first one is private user sandboxes. It means that we have made it using Postgres, and there is a schema for each and every user that is private. And here we have multi-tenant architecture. It means that multiple users they will be accessing the same instance, but none of the instance or the none of the user will be interfering each other. We have deep AI optimization. So here we have trained our LLM in a way that as soon as it sees even the smallest of problem with the query or it can be optimized, then it ensures that yeah, it will give you suggestions and it can be done in a better manner. We have a real-time dashboard. It shows us the index rate, throughput, metrics, and all of the stuff. And we have also a secure authentication because we have used the JWT, and JWT, as you know, it's JSON Web Token, and it basically ensures that the user making the request is he valid or not. And we also hash our password using Bcrypt, and we have also used our Monaco Visual Studio Code editor, and we have also given multiple themes because every user they like some or the other theme, so we want to make sure that users enjoy using our website. And here we have used tech stack for backend. Mainly we have used Node and Express. For frontend we have used Next.js, React, Monaco, and for database we have used Postgres, because the only reason we used Postgres is because it gives us multi-schema isolated environments, which is not possible in SQL. And for security we have used JWT and Bcrypt. So this is basically our repository. And now the best thing we could do is that practically show you how this thing works. So let's just go that the website is SQLens wire Versal.app. I will make sure to put the link of this website in the YouTube description. And like as I'm already existing user, so I will just register with my credentials, and once my credentials are gone, then it will be authenticated, it will be compared with the database, the hash value, and if I'm authenticated, then we will be able to moving on to the dashboard. So here you can see that we have already logged in, and you can see that this is basically our dashboard. So like now we haven't done much with our queries. We are just a new user, and we cannot see a lot of things here. And we can see that the backend uptime is 20 minutes 10 seconds. So it basically stores it in a form of our session, and it refreshes session every time. And here the main part is Workbench. So Workbench, it basically gives you a platform where you can write your code. And the best part that I like is that here we have a lot of themes, and personally my favorite one is Twilight. So it is a very good theme, so users they don't feel bored of using single theme again and again. So let's just say that I want to run a query, show databases. So once I run this query, you will see that user underscore one underscore d1, user underscore one underscore db1, and user underscore one. So what happens is that I was the first user that logged in this website. So I by default I have been given one ID kind of type that is basically auto increment for each and every user that logs in. And here you can see that for user underscore one, I have created two databases, D1 and DB1. So we will also see that, so that I can show you guys the proof. So use DB1. So we will run this query, and here you can see that database changed to DB1. And also uh, we can, let's just say we will just create a table uh, employees, and what we'll do is that we'll basically have two fields as of now. First one is ID int, and second one is name, and let's just keep the length as 20. So we will run query, and here you can see that our query has been executed successfully. But here we can also see one more thing, that is intelligence. So let's see where it is. So here in intelligence we are suggested that we have created table without a primary key. So it is one of a suggestion that if we create a primary key in our table, it will be much better, because if we want to link our table with another table by the foreign key constraint referential integrity, then it will be much easier. So this is where our LLM model comes, that we have trained. It will give you suggestions on each and every query that is wrong. Let's try it one more time. So once we have created this table, we'll basically write insert into emp values, and firstly we'll give id as 12 and we'll give name as John. So once we run this query, there's nothing wrong with this query. You have just inserted the values, nothing else. So you can see that insert executed successfully, one row is affected. So one row has been added, and we will just select star from emp. So we will write this query because we want to fetch all the users. So you can see that we have got one result that we just put right. So here you can see that we are given two more suggestions. First one is avoid using select star in production. The reason it says avoid using select star in production is because when you are working with a very huge database in production level environment, then there is a lot of records and there are a lot of columns. So basically fetching each and every column, it's a very hard task and it takes a lot of time, and it's not a very good practice. And the second one is consider adding limit to your select. It means that whenever we use a select query, then we should use limit to ensure that we only get limited data and the full table scan doesn't happen. So you can see that our LLM model is working very much perfectly here. And let's just say that we will write one very dirty query. Okay, so for that dirty query, we will just see this query, and this is a very unoptimized query. So we'll just copy this query and we will paste it. Okay, so here what we are doing is that basically we have created a CTE. We have created two CTEs, sales data, store performance, and rank stores. And then we have selected, and then we have just written case statement where we have given some of the conditions using when else. And we are using also we are also joining it using store id that is on both the tables. And we will just run this query. So once we run this query, you can see that it took 3 or 5 seconds to execute, right? And like, as you know that we are randomly generating the results. So you can see that there are a lot of results that have been generating, and to be exact 4986, right? And we are also given suggestions that order by without limit, high cost operation, the sorts took place, 5009 rows in memory sorting. It's not a very good practice. So here what we can do is that to make sure that this problem doesn't occur and to find a solution, we will create on deep AI analysis. So it will go to our AI, it will call, and it will just give you the suggestions based on the problems that we are facing. So here you can see that these are the suggestions that are given to us by AI, and it's very good. And now the main thing is that we have also created execution plan. So execution plan lets you know that if you're writing a bad query, then how much time will it take for each and every task to happen. So firstly, here we can see that our data is being sorted. So there are total 5009 rows. The cost is this much, the time is 3 seconds. It used 100% of our cost. Then we did a function scan, it did this thing, and then we did a hash join. And then as I said that we have a lot of CTE, so it did a CTE scan, then it again did hashing, and as you know that we have subquery. Then also we have aggregation, we have sort, we have subquery, aggregation, and one more CTE at the last. So the best thing is that it also shows you like where you can improve and where your cost is being used, where it should not be used at all. And here also, like, once we have written all the queries, you can go to analytics and you can see that this is basically our throughput. And you can see the detailed latency breakdown. So as soon as we wrote a bad query, the one that we wrote recently, it basically shows the latency. It is almost around 300 ms. And it also shows that our index hit rate is this much. And we can also see logs. So in logs we can basically see our queries that have been successful or that haven't been successful. So you can see that our recent queries are all success, and the one that we wrote such as show db show database earlier, they basically got failed. And we can go to overview, and also like we can see that our recent slow queries were this one that took around 3 seconds to run. And also it shows one slow queries that took 250 ms. So basically a query that takes more than 2 seconds is a slow query. So this is how it works. And also like we have like for database we have used supabase. So I'll also run one more thing to ensure that all the users, they have their private isolated environment and it doesn't affect each other in a multi-tenant environment, because that is one of the things that we need to look after, right? So you just basically go to SQL editor, and we have one command pasted. So basically it shows you the information schema of each and every user that has been created, and we will just run this. So here you can see that result. So user 1 is basically the user that is currently accessing this, and user underscore 1 created a db1 after he logged in, and then at some point after logging out he also created d1 database after logging in again. Similarly, you can see that there are user 2, user 3 and user 4. They have also logged in, but they haven't created in database. Then user 2 created a database 1. So here you can see that all the things are working perfectly. And also we will just write select star from users. So we will write this query to ensure that the users that I've shown, they are actually there. So you can see that Chahil1817, the one that I'm currently using, I created two databases. So my schema is user underscore 1, and you can see that there were two databases, d1 and db1. That is same for user 2 and user 3 and user 4. They are just dummy users I created, but that's why they don't have any database. Okay, so basically that was everything for our project that you needed to know. And thanks for watching, and see you in the next one.